Next up is Sturla Sæther, Chief Engineer in Equinor. He's going to speak to us on energy system modeling and the connection between electric and heat energy systems. Briefly on a phone, or at least impressive fact. So Sturla has been working on a combined cycle system for an FPSO in Brazil. As a result of this development, they will be saving 3 million tons of CO2 in the project period. So that's a good one. Okay, Sturla, please.
Yes, thank you. I think I will focus on, let's say, the total energy system. We have discussed a lot here how we can utilize excess electricity from renewables and things like that. So that's my theme here. But first of all, I would like to say something about the updated strategy from Equinor. We have, as you know, high focus on hydrogen, on CCS and things like that. But now we have also integrated system integration into the strategy. So this means that energy systems for heating, for power and everything is included in our strategy. So this is now focusing very much on this. And I think also my presentation is focusing a little bit more to Europe compared to Norway. As we have discussed there, Norway have some specialities related to call it lack of water distributed heating systems and things like that. So I will go further on here. So I think a renewable energy system in the future will of course have a lot of challenges related to wind and solar. They will increase the difference in power cost, and of course we will increase the need for energy storage. So it's really important to, and as Miljøvernforbundet told earlier today, it's when the wind is blowing very hard, 2, 3, 4, 5 days, it's a lot of excess energy available. How should we utilize that? That's really important. And I think also economics will be very important to find the best solutions. And as a result of that, we can say that in Norway now we see that some projects are stopped. The CCS at what you call it in Oslo, the municipal waste there is stopped. It's a lot of expensive projects being stopped. So we need to find good solutions. And I think this complete system, energy and heat together, are really important to look at. And also one big issues for the future are what will really be the power cost. We see now that the variations are really huge. Last weekend in the Netherlands, it was really negative cost of power, -2 kroner or something like that. So it will be a very unstable system on how to utilize that. And it's not easy to say what this exactly will be, but I think one important thing is to make simulation tools to try to estimate what could be the answers, have possibilities to do sensitivity analysis. And Equinor is working a lot on this now, and they have also been part of a project in the geothermica call, Smart Energy System, AeroNet call, which is very highly focusing on this sector coupling between electricity and heat demand. How should we utilize the excess electricity into the heat system? That will also be, can geothermal, for example, be a heat provider? Can geothermal be a heat storage for weeks, months, maybe seasonal storage? And what will be the need for storage? Will it be months, years, whatever? I think we need to find simulations tools to give some answers on that. So what is really sector coupling of heat and why it is so important? So I think it's to utilize the surplus cheap electricity for heat demand shows that you have increased the flexibility in the power system. And you can have the co-firing with electricity and natural gas for heat supply. That's a typical issue for Europe. And thermal energy storage is really cheap and flexible compared to a lot of other systems, and especially for low temperatures, for example, district heating, hot water storage. As residential, you can have a larger hot tap water tank. Should that be only 200 liters as we have today, more or less? Could that be 5 times as big? So we utilize this opportunity. I think also by introducing these systems, you can reduce the curtailment of solar and wind power really much. And what is really the fact is that the heat energy demand in Europe is really huge. It's 1.5 to 2 times as large as the power demand in itself. So the heat is really important. And what also is one of my point here is to see that if we have the flexibility to use our e-boiler, it can ramp up very fast. So it can also be used as a frequency controller. The same as heat pumps, they can ramp up very fast if you design it for them. So it's not only the producer that can handle this grid system ancillary services. As a user, as a consumer, you can also serve these services. So that's really important. So in my opinion, flexible heat demand can be a game changer for large implementation of renewables. And you see Europe, as the result of the Ukrainian war, they are fighting to get less dependent on natural gas. It's really hard, of course, for they use a lot of it, but they try as best they can. And we see also that the export from the Norwegian continental shelf will decrease dramatically the next years. So what will Europe really do? How will they act? And what is the most efficient solutions for them? It's the flexible offtake of surplus electricity, how to utilize that, what's the best systems? And how can we give the best offers for wind farms? I can tell from example from, it's a open wind bid in the Netherlands now, and then authorities are focusing very much on how can this wind bidder give a flexible electricity demand as an offer in the bid. So if you can offer 1 gigawatt extra electricity flexible power, you will get a lot of points to get the total bid. And in my opinion, I think one important thing is this cross-sector coupling is really an answer to be able to utilize this flexible or surplus electricity power. And of course, as I discussed a lot, energy storage by geothermal can be one important issue here, in my opinion. And so to the next, what is really the expectations on the power demand for the future? This is picked from the energy perspectives in Equinor. Equinor is trying to predict the future, and we have 2 scenarios. It's to the left there, it's the power demand based on this wall scenario, which is the more or less the current market trends. If we continue to as the same basis as today, or we have this bridges scenario, which is call it the green scenario. It's the most optimistic scenario related to get green technologies into play. And we see the general here is that the demand for power is really increasing. It's close to doubling in the 2050. And we see to the right-hand side here, we see that this yellow is solar, wind is of course big, and we see the reduction in coal, oil and gas is reduced a lot in these graphs. If we go to the buildings energy perspectives, and this is also picked from the Equinor estimates, we see that energy demand for heating demand is really huge. I have tried to explain that 3.5 ton oil equivalents, it's close to 40,000 terawatt hours of energy. So it's really a huge amount of energy. And you see from the most optimistic scenario, this bridges scenario to the right, you see that electricity is a huge supplier into the heat market. And then, of course, we discussed here today earlier, we should not use electricity into the heat market. But I think if we use heat, supply heat by heat pumps, I think that's really a good way to do it. And I think when we get this surplus electricity in huge amounts, we need to take that flexibility. E-boilers will, of course, play some role, but if we can utilize heat pumps, it will be really good. And this is also for the GEO market. The space heating market for GEO is, as you say, see here, it's close to 4,000 terawatt hours a year for space heating and tap water demand. The electricity demand in GEO is close to 3,000 terawatt hours. So we see that heat is really playing an important role. And also gas boilers, that are the red here. So it's really a huge use of gas. And I think the substitution of gas by electricity, by heat pumps, by geothermal, by everything will play a very important role. And I think that's really there where the sector coupling potential will come into play. And this is some background, and I have picked some results from some simulations we have been doing. We have a good collaboration with SINTEF to look into how the future can be. And here are 5 different scenarios. So we say that we install a wind park, and to the left bar we have a wind park serving only the electrical grid, and this system here have gas boilers. GB is a gas boiler, so the bar to the left, we supply all the heat by gas boilers. So to the left, it's no electricity for supplying the heat. If we introduce hydrogen as an option, which is somewhat costly, but if that's an option, we see that on the bar number 2, that 36% of the heat will then be supplied by hydrogen. The rest is still gas from the boiler. If we then go to bar number 3, then we allow electrical boilers to come into play. And then we see that we shift quite a lot of the gas into electrical boilers. So 77% of the heat is supplied by electrical boilers. And the 4th bar is when we introduce heat pumps as an alternative. Then we see that the heat pump will almost cover 97%. So almost all the gas is substituted by a heat pump, because that's, in this case, economical benefit. And the last bar, when we, in addition to this, we also introduce a thermal energy storage, we increase the flexibility even more. Then it's somewhat interesting result. And then we see that we are close to 100% electrification, but we see that the heat pump will play a minor role compared to the electrical boiler when we have this thermal energy storage into play. But I'm first to say that all these results are, of course, depending on what prices you are set to the electrical grid, what will be the price of the natural gas, and what will be the price of whatever. But I think when you have this kind of simulation tools, you can do sensitivities, you can see what type of technology that will be most attractive under the certain conditions. So I think it's really important to have these results and start to play with new technologies and at least have the best economical inputs that you can have.
So 5 minutes.
Yeah. So I think in general, the needs for flexibility and use of surplus electricity into the heat market is really something important and that we should focus on. And what I like to say that this transfer from natural gas into electricity, it has already started. Europe has already started this sector coupling already. If you look into Berlin, Vattenfall Wärme, they build now a very, very large tank for hot water storage in connection with their district heating system. And we see also in Esbjerg, Denmark, they are now introducing a heat pump supplying 50 megawatts of heat by using surplus electricity from the wind parks, windmills around. They use the heat pump they run it very hard, very tough, and the electricity is cheap, store energy into the thermal energy storage, and deliver heat when it's needed. And what is important also said by the Vice President of MAN is that sector coupling is an essential key to climate neutral energy future. In Vienna, they are also using a large heat pump now to produce heat into a district heating system. They're using municipal, they use the wastewater to heat as a heat source for this system. Denmark, building the world's largest thermal heat storage pits in Vojens, huge pit. You can see the bracket and some in what do you call it, gravemaskin down to the right there. And so it's really huge. And in this type of storage, they store this solar energy from summer to winter time. So main points, sector coupling of heat. I think Europe is asking for flexible extra electricity demand to avoid curtailment in renewable power generation and improve the income in renewable projects. And that's to not need to stop the windmills and not to stop the solar when there are too much of it. And heat has a very large potential for flexibility. You have this water-based system. It's really cheap to store it and a very good energy efficiency by using heat pumps. And as I said, auxiliary services as frequency capabilities and electrical grids can be utilized by the consumer of power and electricity, not only the producer. And of course, if you substitute natural gas, this will be a very good CO2 emission effort. I think how much of the market can be covered by this? And what will be the needs for more extreme and expensive alternatives? By discussing a lot in Norway, can we produce hydrogen, export hydrogen to the energy systems in Europe? How much of will then be the needs for that? Can the more cheap sector coupling of heat and electricity take a lot of this market? That's a big question. So, then I'm finished.
Thank you very much. So, any questions from the floor?
We had a high focus on geothermal some years ago. We was participating in the Iceland deep drilling project. And then the strategy was turned more or less down to geothermal. So we have not very high focus on it at the moment. We have high focus on lithium extraction from brines. So there we see that if you can combine that with geothermal, it can be a business. But it's more focused on this lithium extraction related to geothermal at the moment.
So you don't believe in geothermal?
I think my personal opinion is I believe in it, but I think Equinor do not. And as you know, Equinor is also looking for really the big project, the big market shares. And I think they say that geothermal will not be a big part of the market. I think they mean more on a world basis as well. But somebody needs to go the opposite. So, but I think, in my opinion, I think geothermal for heating purposes is really something in the future. I don't believe so much in power production. Then we need to be at Iceland, or we need to be at the very hot. So I think if you have a heat source of 120, 130, 40 degrees, it's really hard to get power running. But I think, as I said here, we need also a lot of heat. It's a huge heat demand out there, even in Southern Europe. So we should be aware of that as well.
Thank you, Ola. Please state your name and affiliation.
You mentioned hydrogen, and the question is, especially today, in the excess of cheap wind power. The project in Sæther about 20 years ago, which I think was Hydro or probably. My question is, what is your strategy for storing the hydrogen when it's generated, the wind power, and it blows a lot? How do you store it before you speak with it?
So personally, I'm not working with hydrogen. So, but I know Equinor has a high focus on this, and we can, as you say, very cheap electricity can be utilized to produce hydrogen or ammonia, and that there are a market in the other hand to use that, and it can be, let's say, the energy, the industry sector, steel production, for example. They need reduction materials. Hydrogen can be perfect there. I think also marine transport has less options, so maybe hydrogen and ammonia can be something like that. But how to store it, I'm not sure. I think ammonia, the way through ammonia is discussed a lot. So it's maybe more easy to store ammonia than pure hydrogen.
We do have environmentally friendly research center for environmentally center for energy, Norwegian in hydrogen. So it's something we could discuss. Okay, so next question and last question, please. And then
shut up on energy. So I was just wondering with the flexibility you're talking about to thermal systems. Is there any requirements on the temperature? Because in Bergen we have 120 degrees Celsius time temperature of the heat pumps and those machines there. So if you want that flexibility, then requirements go lower.
I think typically the storage of hot water, you need to be below 100 degrees. And if you have a really huge tank, I think it's best to have it atmospheric. But you can, of course, if you go to the ground, I'm not sure if you can store hot water at a certain pressure that you can increase your temperature. But I think to get really the best thermodynamical options, you need also to look into your district heating system. Should you lower your temperature? If you should use electrical heat pumps for district heating, I think the temperature can be lowered. And that's what they have been doing in Denmark for years, to have it much lower, to have the best utilization of as they used to have the coal-fired power plants. So a lowest possible heat supply to get the best efficiency in total. So I think we need to discuss that as well for the future. You should not supply 120 degrees in the district heating if you can get it more beneficial to do less. And then it's really easy to store hot water at 98 degrees. The storage tanks from Berlin, it's 98 degrees below the boiling point.
Okay, thank you very much, Sturla Sæther.